So one other principle, property that's important is this idea of magnetic properties. So atoms and ions with unpaired spins interact with the magnetic field, and they're called paramagnetic. So for example, silver, if we remember, it has a krypton, 5s1, 4d10. So all the 4ds are paired, but there is one unpaired electron, the 5s electron. And so if you have a magnetic field, ions will interact with that magnetic field. However, atoms and ions with all paired spins do not interact with the magnetic field and are diamagnetic. Diamagnetic means that it does not interact. It's actually slightly repelled by a magnetic field. Here, we have all filled shells. All of the electrons are spin paired, and therefore it is diamagnetic. It does not interact with the magnetic field, because that if you have like a surplus of spin, you get an extra +1 or minus extra +1/2 or -1/2, then the angular momentum that's associated with that spin will interact with magnets. However, if we have Ag plus, then we know what we have there, the 5s goes away, and that will be diamagnetic. So the atom is paramagnetic, and the ion is diamagnetic. So there's one other type of magnetism, ferromagnetism and ferrimagnetism. Those involve unpaired electrons and arrangements of atoms and crystals. So you can't look at just the, and that's the sort of permanent magnetism that we'd see in refrigerator magnets. So again, that involves both unpaired electrons. You need to have unpaired electrons to get ferromagnetism, but you also need to deal with the arrangements of the ions and the atoms of the crystal. So we're not going to deal with what's ferromagnetic or not. That takes more information than just the information you see in the individual electron orbitals. What we can say is whether things are paramagnetic and diamagnetic, and all we do is write out the electron configuration and count the spins, see which spins are unpaired and which aren't. So for example, nickel, is that paramagnetic or diamagnetic? So let's write out the electron configuration. So we have, it has, it's 28 electrons. It has an argon neutral gas, noble gas configuration. Then we had 4s2, 3d8. So let's start filling it out. Those are going to be the 4s electrons, then 1, 2, 3, 4, 5 argon. And so first we fill out the 4s, and then we start filling up. And remember Hund's rule. The first 5 are all spin parallel, and then we had 3 more. So 1, 2, 3. Aha! We have 2 unpaired electrons here. They don't line up in parallel. If they lined up, you filled each orbital in sequence, then it would be diamagnetic, but we don't. First, we fill all them in with unpaired electrons, and then we fill them up pairing. So it has to be paramagnetic. We have 2 unpaired spins. So that's important. Hund's rule is really important here, that first you fill in, you fill all the orbitals half full.